Hello everyone, welcome to Chemazon-Complete Chemistry. So in today's video, we're going to discuss questions on aromaticity that were asked in the previous year IIT JAM question papers. So you can see almost every year, at least you can find one question that is fixed from aromaticity. In 2022, 21, 20, it was not asked in 2018, then 17, 16, 15, not asked in 14, so 13, 12, 11, then it was not asked in 10 and 8 and 7, 2008 and 7. But you can see almost every year there is one question that you will see from aromaticity that we are going to solve in this video. Okay, and if you've not seen the last video where we had discussed what are the conditions for finding out whether a compound is aromatic, anti-aromatic or non-aromatic, I will provide the link in the description. You can watch that. So this is one of the question of of JAM 2019. Okay, so let us first solve this question that was asked in JAM 2022 paper. So this was asked in numerical answer type. Okay, that means you have to insert one number or integer. Okay, so first molecule you can see this is what cyclooctatetraene. We had seen this is what this is non-planar. So this is going to be non-aromatic. It has tub-shaped structure. It is not planar like this. Okay, it is non-aromatic. Here again you can see there is an sp3 hybridized carbon atom, so this is also non-aromatic. Okay, this one if you see what we can do here, carbonyl is polar because this is oxygen is more electronegative, this will be delta plus. So what I can do, I can make this double bond single bond. What I'm doing is this pi electrons will shift on the oxygen atom. Okay, so this will become single bond and here oxygen will have 3 lone pair negative and this will become positive. Now if you concentrate on this ring, there are how many pi electrons? 6 pi electrons, or as I told you earlier, what is the shortcut to finding out the aromatic compound? It should have odd number of double bonds. Okay, if it has odd number of double bonds, then it will be aromatic. And anti-aromatic, it should have even number of double bonds. If the molecule has even number of double bonds, then it will be anti-aromatic. Okay, and one more thing, negative charge means that it comprises of 2 electrons. So this we can consider as one double bond. Okay, now let us see. There are 1, 2, 3. 3 pi bonds, so it will be aromatic. Okay, here you might think that 1, 2, 3, 4, 5, 5 double bond, that is odd, so it should be aromatic, but it is not going to be aromatic. Why? Because here if you see, there is one hydrogen like this and there is one hydrogen like this. So because of this two hydrogens which are very close to each other, these are out of plane of the paper. So it is what? It is not going to be aromatic, it is non-aromatic. Okay, this one. Here first what you have to know is that the nitrogen lone pair, for this nitrogen it is outside the conjugation, that is outside the ring, whereas for NH here the nitrogen is inside the ring. So it is involved in conjugation like this. So total there are how many electrons? 6 electrons, or we can say 6 electrons, so it follows Huckel's rule. So it will be aromatic. Similarly, this is also going to be aromatic because one lone pair of oxygen is involved in resonance. Okay, so this is also aromatic. It is which molecule? It is furan. Now here, the first condition for finding aromaticity is that it should be cyclic. This is acyclic. Okay, so this is neither aromatic nor it is not aromatic. It is not anti-aromatic. Okay, so this is not going to be aromatic. Here if you see 2 plus 2, 4, that is 2 bonds. That is even double bond, which means it is going to be anti-aromatic. Or we can say it follows 4n pi electron rule. Now this, if you see again 2 plus 2, 4 electrons. So this is also going to be anti-aromatic. Okay, here 2 plus 2, 4 plus 2, 6. That is 3 pi bonds. So this is going to be aromatic. Here nitrogen, both the lone pairs are outside the conjugation. Okay, they are not involved in resonance. So 2 plus 2 plus 2, 6. So this is also going to be aromatic. Okay, this ring, if you see here, 1, 2, 3, 4, 5, 5 double bonds, that you might think that it's going to be aromatic, but it is not aromatic, because you can see this is sp3 hybridized carbon, this is sp3 hybridized carbon, this is also sp3 hybridized carbon. So the molecule is not planar. Okay, what are the conditions? First is it should be cyclic. Second, it should be planar. Third, it should be having conjugation. Okay, conjugation means resonance. Okay, and fourth is that it should have 4n plus 2 pi electrons. These are the conditions for a compound to be aromatic. So this is going to be non-aromatic. Okay, so now let us count how many of them are aromatic. How many of them are aromatic? 1, 2, 3, 4, 5. Okay, so 5 compounds are aromatic. So what is the correct answer here? You have to insert the number 5 like this. No decimals, nothing. Okay, now this was a question asked in 2021. Option A, you can see this is sp3 hybridized carbon. Okay, so you will see in the coming question, many molecules are going to be repeated. Okay, so this is what? This is non-aromatic. Okay, what is asked in the question? Anti-aromatic compounds are asked. Anti-aromatic means it should have even double bonds. 1, 2, 3, 4. This is anti-aromatic. Yes, this is going to be anti-aromatic. If we see option C, 1 and 2, this is also going to be anti-aromatic. Okay, I will do one thing. For aromatic, I will write single A. For anti-aromatic, I will write double A. And for non-aromatic, I can write Na. This way we can save some time. C, this is going to be anti-aromatic. Option D, it is also anti-aromatic because it has even pi bonds. So what is the correct answer for this question? The correct answer for 39 question in 2021 is B, C, D. This is which type of question? MSQ, multiple select question, that is more than one type, more than one answer is correct. Now this is the question that was asked in JAM 2020. So we have to determine what? We have to write down the rate of solvolysis. Okay, solvolysis means what? Whenever you add an alkyl halide in some solvent, let's say water. Okay, it is stabilized, which means it will form a carbocation and it is surrounded by the solvent molecule. This is nothing but solvolysis. Okay, that is this bond is broken and it is surrounded by the solvent molecule. So what we have to do is we have to find out the rate of solvolysis. So rate of solvolysis, it is directly proportional to the stability of the carbocation. Okay, so what we have to do is for all the molecules we have to draw the carbocation and check its stability. So first one is, okay, I will straight away draw the carbocation. It is a bridge compound and Br minus goes away, so the carbocation will be formed here. In second case, carbocation is formed here. Third one, carbocation will be formed here. So what we have to do is we are removing Br minus. Okay, in all the cases we are removing the leaving group and we are forming the carbocation. Okay, let us see the last one. Here this is the carbocation formed. Now what we can do is, this is indirectly related to aromaticity. So the aromatic compounds are going to be most stable. So they will have the maximum rate. So here if you see, there is one pi bond, that is odd number of pi bonds. So this is aromatic. Okay, so it will have the maximum rate. So 3 will be maximum. And anti-aromatic compounds are least stable. That we will see the stability we will see in the next video. What is the order of stability? Aromatic compounds are most stable, and then non-aromatic compound, and the least stable is anti-aromatic. Okay, so fourth one, if you see, it has even number of pi bonds. So this is what? This is anti-aromatic. Okay, so this will have the least stability and the least rate. So the rate of fourth one will be least. So you can see there are only two options where this is the order. A and D are incorrect. Okay. In this way, you keep eliminating the options so that it becomes easier. Now, between 1 and 2, which is going to be more stable, this is going to be more stable because it is tertiary allylic carbocation stabilized by resonance. Whereas if you see the first one, always remember at the bridged carbon, carbocation is very unstable. Okay, this is going to be very unstable. Why? Because according to the Bredt's rule, okay, carbocation formed at the bridge carbon is very unstable because what is the reason for the carbocation being unstable? We know that the carbocation, it is sp2 hybridized. Okay, so it should be trigonal planar. But at the bridge, you can see the geometry is such that it cannot remain planar. It is not planar. That is the reason it is very unstable. Okay, it should be trigonal planar, but it cannot remain trigonal planar because of the bridge. Okay, so the rate of the first alkyl halide will be least. Okay, less than the second one. So this is the correct order. 3 greater than 2 greater than 1 greater than 4. So the correct answer is option C. So the correct answer is option C. Now let us see the next one. Here, this was asked in JAM 2019. It is again an MSQ question. More than one answer will be correct because is or R is given. So what we have to do is, for all the options, we have to write down the product and then we have to find out whether the product will be aromatic or not. So let us first write down the first one. This is a three-membered ring, Cl plus SbCl5. So what will happen? This is a Lewis acid. Okay, this is an acid. So it can accept the lone pair from this chlorine. Okay, like this. And what we will get is, we'll get something like this. It has donated lone pair, so it will have positive charge. Positive charge on an electronegative atom is not stable because it is an electronegative atom, so it wants what? It wants electrons or negative charge and not electron deficiency. So this will break like this. What we are going to get is, we are going to get this carbocation. Is this aromatic? Yes, it has odd number of double bonds, so it is aromatic. Okay. B, Br plus AgBF4. What AgBF4 is? Ag plus and BF4 minus. So Ag plus can react with Br minus to form AgBr. Okay, so AgBr will precipitate silver bromide, and what we will get is this compound. It has even pi bond, so it is what? It is anti-aromatic. C option, pH, pH. Okay, here we have H and COPH. Now NaH, sodium hydride, it is going to be a strong base because H minus can take proton and it becomes H2. H minus, if it takes proton, it can form stable hydrogen gas. Okay, so it will pick up a proton. A negative charge will be on the ring. What will it form? Okay, before that, why it is stable? This will be stable because it can undergo resonance with a carbonyl group. So that is why this anion is stable. So what is the product that is formed? pH, pH, negative charge. Now there are two 4 pi electrons. That means it is going to be anti-aromatic. Okay, now last one, D. D option. If we see what it, how it will happen. Here there are two hydrogens. Here there are two hydrogens. So what will happen? It will undergo homolytic cleavage. It will break like this. So there will be one electron here on the carbon, and simultaneously sodium, it belongs to group 1, so it can donate one electron. So this electron from sodium, okay, here what will we will get? We will get two electrons, that is negative charge. Okay, one electron was from the CH bond, another electron was given by sodium. So now if you see there are how many electrons here? 2 plus 2, 2 4, 4 plus 2, 6. So it is going to be aromatic. Okay, it is going to be aromatic. So what are the correct answers here? You can see which of the two options are aromatic. Option A, here we will get aromatic species. B is anti-aromatic, incorrect. C is anti-aromatic, incorrect. D is aromatic. So D is also correct. So option A is correct and option D is correct. So what are the correct answers? Option A, comma D. 2017. Here again, if you see, we have to find out the number of aromatic compounds. So here again, this one lone pair of oxygen is involved in resonance. So 2 plus 2, 4, 4 plus 2, 6. Here it is sp2 hybridized carbon, so it will have a, it is sp2 hybridized carbon, so it is planar. Okay, so 2 plus 2, 4 plus 2, 6. So total there are 6 pi electrons, so this is going to be aromatic. Here the nitrogen lone pairs are involved in resonance. So 2 plus 2, 4, 4 plus 2, 6. So this is also going to be aromatic. Boron, it has an empty p orbital like this, but it has how many electrons? Even number of double bonds. So this is going to be anti-aromatic. This molecule, again here, this nitrogen lone pair is involved in resonance, whereas the other nitrogen lone pair is not involved in resonance. So 2 plus 2, 4, 4 plus 2, 6. This is also going to be aromatic. And last one, here one lone pair of sulfur is involved in resonance like this. So 2 plus 2, 4, 4 plus 2, 6. This is also aromatic. What is the name of this? This is thiophene. So 1, 2, 3, and 4. 4 molecules are aromatic. So here answer will be 4. 2016, the number of molecules that are aromatic is or are. Okay, so this is a NAT question. Again, we have to insert one integer. Okay, 1, 2, 3, 4, even number of double bonds. This is going to be anti-aromatic. This we had already seen. This is non-aromatic. 1, 2, 3, 4, 5. Odd number of double bonds. This is aromatic. 1, 2, 3, 4, 5, 6. Even number of double bonds. This is anti-aromatic. Now this molecule, what I can do, I can make this aromatic by shifting this pi bond electron here. Okay, negative charge. Here we will have positive charge. So you can see 2 plus 2, 4, 4 plus 2, 6. 6 pi electrons. So this is aromatic. Here if you see 1, 2, 3, nitrogen will have lone pair 4 and 5. So total 10 electrons. So this is also aromatic. This we had seen there is repulsion between these hydrogens, and because of which it is non-aromatic. Here last one also, again if you see, this is not planar. This is sp3 hybridized carbon. This is also sp3 hybridized carbon. The entire molecule should be planar. If you count the pi bonds 1, 2, 3, 4, 5, 6 and 7. If you count pi bonds, you might think it is aromatic, but it is not aromatic. It is going to be non-aromatic. So how many molecules are aromatic here? 1, 2 and 3. So there are 3 molecules that are aromatic. So the correct answer is what? It is 3. Now 2015, this question, again this is of NAT type, NATs. Okay, what we have to find out, which of the following are aromatic? All the three nitrogens here, the lone pair will not be involved in resonance. Okay, so 2 plus 2, 4, 4 plus 2, 6, odd number of double bonds. This is going to be aromatic. Okay, so this is one correct option. Oxygen, lone pair will be involved in resonance. So this will be involved in resonance. 2 plus 2, 4, 4 plus 2, 6. So B is also correct. C option 1, 2, 3, 4, 5, 6, 7. Odd number of double bond. This is also aromatic. Okay, B is also aromatic. C is also aromatic. Last option. Here both the lone pairs of oxygen will be involved in resonance. 1, 2, 3, 4. So even numbers. So it will be anti-aromatic. Anti-aromatic. Question, it is asked which are aromatic. So the correct answers are A, B, C. Next one, this is calicine. It is a polar hydrocarbon with high dipole moment. The most stable dipolar canonical structure. So what we have to do is, now there are two things which we can do in this molecule. Okay, we have to break this double bond in such a way that this molecule becomes stable. That is, both the rings should be aromatic. So let us break both ways. Suppose one is a blue one, I shift this electrons here. What I will get? Negative charge here, and here there will be positive charge, like this. Okay, and other possible structure will be, I shift this electron on the smaller ring. Positive, negative. Now we have to compare both the rings. Here if you see this ring, 2 plus 2, 4, 4 plus 2, 6. So this is aromatic. Here there is 2, 1 odd, 1 pi bond, that is odd number. So this is also aromatic. Okay, so this is going to be the correct structure. Second structure, if you see here, 1 plus 2, even number of pi bonds, that is 4 pi electrons. It will follow 4n pi electron rule, that is, it is going to be anti-aromatic. Here also 2 plus 2, 4. This is also anti-aromatic. So this is unstable. Okay. So what is the correct answer? The correct answer for this structure will be, the larger ring will have negative charge and the smaller ring will have positive charge. The species or compounds that are aromatic among the following are. Okay, so first one, here there is only one pi bond, so this is going to be aromatic. 1, 2 pi bonds, even number, this is anti-aromatic. Here, this is sp3 hybridized carbon, so this will be non-aromatic. Here 1, 2, 3, 4, 5, 6 and 7, odd number of pi bond, this is going to be aromatic. So which is aromatic? P and S. The answer is option D. This question, the products P and Q in the following reactions respectively are. So this reaction is similar to the question that we did in 2019. That is, we have to do the reaction and find out the product. So which is the most acidic protons? Here these two are the most acidic protons, and here this is the acidic proton. Why? Because this NH2 minus is a strong base. It will abstract this proton and we will get which structure? We will get this structure, negative CH3. Here Ag plus, here what will be the reaction? There is no acidic proton. Here it is Ag plus, so Cl minus will go away. Okay, this we had already seen in the 2019 question. So what we will get? We will get this structure. Positive charge here, CH2Cl. Okay, now if you see here, there are how many electrons? 4, 2 plus 2, 4, 4 plus 2, 6. So this is aromatic. So that is why this is going to be stable. And here this is also having odd number of pi bond. This is also going to be aromatic. Okay, so these are the two structures that will be formed. Okay, which is the correct answer? Correct answer will be option C. Correct answer is option C. Let us see the next one. 2009. Which of the following are aromatic? This is sp3 hybridized carbon. This will be non-aromatic because it will be non-planar. One hydrogen will be below the plane, another hydrogen will be above the plane like this. That is why this is going to be non-aromatic. Option Q, 1, 2, 3, or 3 pi bonds. This is going to be aromatic. 1, 2, 3, 4 even. So it will be anti-aromatic. S, 2 plus 2, 4, 4 plus 2, 6. This will be aromatic. So which are aromatic? Q and S. So the correct answer is option D. This is the last question of 2006 paper. The increased order of acidity of the following hydrogen in bold italics among the following is. So what we have to do, we have to find out the acidity of these protons. So what we can do is, acidity means loss of proton. So what we will be left with is the negative charge here. Okay, negative charge here. Now, if you see this, this is going to be least acidic because this is unstable. Okay, acidity is what? Acidity is directly proportional to the stability of conjugate base. Okay, what is conjugate base? The structure formed after removing H plus ion. Okay, these are the conjugate bases. So this is anti-aromatic. Okay, so this will be least acidic. So find out where this is the second one is the least acidic. C and D. Option A and B are eliminated. Now we have to see between 1 and 3. So there is a concept of annihilation effect. What is the meaning of this? As the number of rings increases, rings, which rings? Fused rings. Fused rings increases, the aromatic character is going to be decreased, or we can say aromaticity decreases. Okay, if aromaticity decreases, stability will also decrease. Stability of the conjugate base will also decrease. Now here if you see, this is aromatic 1, 2, 3. Okay, this is aromatic. And here if you see 1, 2, 3, 4, 5, 6 and 7. This is also aromatic. But which is going to be more aromatic? Option 1. Okay, it will be most acidic. So the correct answer will be option D. But why the 3 is less aromatic? Now that is the question. Okay, so if you see first the structure, here this was aromatic. Now if I add two benzene rings like this, okay, two benzene rings, I will get the third structure. In third structure, what will happen is this middle ring was aromatic. Now the aromatic character will be shared by these two rings. So overall, the third structure is going to be less aromatic because of this annihilation effect. Okay, that is the number of rings are increased. So the aromaticity gets shared or the overall aromatic character decreases. So that is why 3 is less acidic. 1 will be most acidic, then 3 and then 2. That is 2 is least acidic because it is least stable. Why? Because it is anti-aromatic. So what will be the correct answer for this question? Option D. I hope you have understood all the questions. Thank you so much.